Welcome to Blue Frontier. Our company seeks nothing less than to lead a revolution in air conditioning. I am Daniel Betts, CEO of the company. As you may have noticed, I have an accent, and that's because I am originally from Panama. This is the Panama City I grew up in the 80s and 90s. At that time, 80% of the country's power came from renewable energy. However, most buildings did not have air conditioning. You were always hot and sweaty. You got your groceries outside and storefronts were open to the environment. Doing business was loud and again, quite hot. This is Panama today. The country has gone through an extraordinary period of economic growth. However, today only 60% of the country's electricity comes from renewable energy. As the economy grew, people bought air conditioners and demanded that the places where they shopped and worked had climate-controlled environments. This story is being repeated with increasing speed across the world. Air conditioning is the fastest growing use of building energy in the world, representing 37% of global demand growth for electricity. This is straining utilities' capacity to keep up with an increasing and weather-dependent variable demand, leading to increasing use of non-renewable energy resources as they scramble to maintain reliable service. In fact, this problem is so big that according to the International Energy Association, air conditioning is the single most critical blind spot in today's energy debate. This is not just an issue of developing nations, however. In the US, air conditioning sets the peak electricity demand in buildings. And when forests burn and when blackouts occur, peak air conditioning demand is most often the culprit. Air conditioning also drives the cost for renewable energy because peak air conditioning occurs after peak solar power production has occurred, causing a phenomenon called the duck curve. So what are we as an industry doing about this? Well, we're installing batteries and we're investing in smart thermostats and building demand management systems, all of which try to mitigate for the inconsistencies in how we use energy and how we produce it in a clean way. Most of the solutions, however, are not dealing with the root problem. The conventional air conditioner, a technology more than 100 years old, produces between 20 to 35% of peak demand in the United States. In fact, it would take 3 Tesla Powerwalls to power a single 5-ton rooftop unit air conditioner. Instead, Blue Frontier is putting our efforts toward fixing the problem at its source. This is our first product, a direct replacement of the ubiquitous 5-ton rooftop unit air conditioner. This air conditioner dominates the commercial building air conditioning market. Our Blue Frontier HVAC is ultra efficient, reducing energy consumption by more than 60%. It also stores electricity in the form of a proprietary low-cost salt solution. Thus, we can shift the unit's electricity consumption to match renewable energy generation or to periods where electricity prices are lowest. And it is just a better air conditioner, capable of independently controlling humidity and temperature and providing better fresh air ventilation than conventional systems, thus resolving the thermostat fight by making everyone more comfortable. All this flexibility and improved performance is wrapped in intelligent controls that enable digital services to building owners and to utility partners. The Blue Frontier HVAC system is comprised of 2 subsystems, a like-for-like replacement to the packaged rooftop unit and a regenerator energy storage module. The regenerator module converts electricity into low-grade heat using a novel heat pump. The heat is used to evaporate water from our salt solution. This high-concentration solution is stored for later use to drive our air conditioning process when required. The salt solution is 4 times more energy dense than ice energy storage and has an energy storage cost that is less than $20 per kilowatt hours if we were to compare it with a conventional battery. When air conditioning is required, the concentrated salt solution is sent to the air conditioning head. The salt solution first dries the air, and the resulting dry air is then subjected to dew point evaporative cooling. The result is an air conditioner that provides better comfort, has better fresh air ventilation, and whose relative efficiency increases as the cooling needs increase. This is what happens when you install one of our units. This is the effect of replacing a building's 5-ton air conditioner with ours. In this case, the building is an outpatient healthcare center in Palm Springs, California. And as you can see, the air conditioning energy plummets, creating close to $3,000 in yearly electricity bill savings. In the life of the unit, This represents more than $40,000 in savings per unit. This result is repeated across building types and climates. These are the results of a study conducted for California. On average, we eliminate 81% of the energy consumption of conventional air conditioners and 87% of their peak demand. We also eliminate the use of high GWP refrigerant, reducing refrigerant-related greenhouse gas emissions by 82%. We far exceed CARB 2025 refrigerant elimination requirements. The company's foundational technology has won the prestigious R&D 100 award and comes primarily from the Renewable Energy Laboratory. Blue Frontier has 8 issued patents and 4 pending patents that cover the fundamental process for our air conditioner, mechanical components, and critical design features. Additionally, Blue Frontier has issued patents that cover the implementation, architecture, and control of the utility-managed virtual power plant. Blue Frontier is marching through the multiple milestones and valleys of death typical of hard tech solutions. The technology was discovered in 2008 at NREL. Since then, it has been prototyped and studied to the point where the feasibility has been clearly demonstrated. Blue Frontier was founded in 2017 by a mix of industry leaders, scientists, and engineers with unique experience in advanced air conditioning technology, thermal sciences, and marketing of grid-supporting building energy efficiency equipment. Since then, we have concentrated our efforts on improving upon prior prototypes, transforming the technology into a low-cost, mass-producible product. With today's design, we have visibility to having manufactured unit cost that is equivalent or lower than the cost of a conventional air conditioner when manufactured at volume. We have been awarded grants from NYSERDA, Wells Fargo IN2 program, Cal Testbed, the Caltech Rocket Fund, and SoCalGas. We have also established partnership with an outsourced manufacturer in New York State. We plan to start field trial deployment of 1,000 units into target markets in New York and California starting in 2022. The goal of this effort is to validate product reliability and quality so that the product becomes financeable, and this will open up a disruptive business model that we call HVAC as a service. The market for our class of air conditioner products is enormous. In the US alone, approximately 2.6 million units are sold per year. However, the HVAC as a service business model breaks a principal barrier to stimulate this market further. Today, most commercial buildings are tenant occupied, so capital cost is more important to the owner of the building than efficiency is. Blue Frontier eliminates this barrier in a way that conventional air conditioner companies just cannot replicate. We become a zero-cost option to building owners and reduce their capex. This opens up the market to the installed base of air conditioners in our class, which are more than 40 million units. Thus, we're talking about a more than $800 billion market opportunity in the US alone.